this is Erika, and I'll be doing number 39 from Chapter 3 in the Physics C textbook. Alright, so let's read the problem. Okay, the problem reads, a radar station locates a sinking ship at range 17.3 kilometers and bearing 136 degrees clockwise from north. From the same station, a rescue plane is at a horizontal range 19.6 kilometers, 153 degrees clockwise from north, with elevation 2.20 kilometers. Part A. Write the position vector for the ship relative to the plane, letting I represent east, J north, and K up. Part B. How far apart are the plane and the ship? Alright, so for the first part of the problem, what we want to do is we want to draw a picture and figure out which information we do have and we don't have. So, just moving. Alright, so what we do know is that there's a sinking ship and a rescue plane. So we also do know where each of these things are. So sinking ship and rescue plane. So we know it's at 17.3 kilometers. And then we know this one's at 19.6 kilometers. And then this way and this way. And then we also know it's 136 degrees from north. From north is a very important point to know. Otherwise, we're going to find the wrong angle. And then if we find the wrong angle, obviously we're going to have the wrong answer. So one's 153 degrees from north, as well as 2.0 kilometers up. Alright, now we're going to draw a picture with the XYZ plane. So in order to do that, we'll first have this axis, and then this axis. And we'll say this one's basically below the sea, so we'll make that a dashed line. And we'll say this is the x-axis, y-axis, and z-axis, and then this one's at sea level. Right? So we're gonna draw the picture of the sinking ship. So we know this is gonna be north, right? And so if it's 136 degrees, it's probably around right here. Let's say that's 17.3 kilometers. This is our grand sailboat that's sinking. And then the rescue plane is 19.6 kilometers, 153 degrees. So that's around here, let's say. And then it's going to go up 2 kilometers, 19.6 kilometers, and 2.0 kilometers. And this is our rescue plane. Sorry for my bad drawings. Alright, so now that we drew a picture, we're going to change this from polar coordinates into Cartesian form so it's going to be easier to solve. That's what we're going to be using to solve part A. So, part A. We're going to label this vector, the sinking ship vector, S, and the plane vector, P. So we both know that it's going to be 17.3 kilometers in the x direction, 19.6 kilometers in the x direction, and it's going to be 136 degrees, 153 degrees, and then it's going to be 0 kilometers up, and this is going to be 2 kilometers up. Alright, so we're going to try to change first the angle, and then we'll try to solve the rest. So for the sinking ship, to find the angle, we know it's 136 degrees from north, right? We want to do it this time from the x-axis. So let's say this is ship, this is plane. So 136 degrees from north, which is going to be the top of here, is around right here. We want to find this angle so that we know what this angle right here is. And this angle, this big one, is what we're going to be using for our calculations. So if you do 136 degrees minus 90, you find this one, and then 360 minus this angle is approximately 314 degrees. Same thing with this one. We know that it's around here, So if we find this angle, we can find this angle right here, which is around 297 degrees. All right, so now we're going to change them into Cartesian form. So the vector S is going to be 17.3 cosine 314 degrees, 17.3 sine 314 degrees, and then 0. Keep in mind that we know that x equals r cosine theta and y equals r sine theta. All right, so if we put that in our calculator, what are we going to get? On here, let's turn off the flashlight. All right, so it's going to be 17.3 cosine 314 and 17.3 sine 314. Just going to give us 12 and negative 12 approximately. 7.5, then negative 12.445. Don't forget the units. I'll forget the units. And then 0. And then now we're going to change the plane vector into a Cartesian form as well. It's 19.6 cosine 297, 19.6 sine 297. Sorry about that. And then this is going to be 2.2 since we already know what that is. If we plug that into our calculator, and then we're going to get 8.89 and negative 17.4637. Sorry about that again. And then so 8.898 and then negative 17.4637 and then 2.2. So part A of the problem asks us to figure out what the sinking ship is in relative to the plane. So basically what this point is relative to here. So in order to find that, we basically just want to subtract SP from S. So this equals approximately 12.0175 minus 8.898, comma, negative 12.445 minus negative 17.4637, and then 0 minus 2.2. Okay, and so if we do that on our calculator, we are going to get it's going to be around 3.119, and then this is going to be around 5.019, and then this is going to be obviously negative 2.2. So if we round that up a little bit, it's going to be 3.12, 5.02, and negative 2.20 kilometers. And now we're going to fix that into IJK form because that's what the answer key wants. So 3.12I with a hat plus 5.02 G with a hat minus 2.20 K with a hat kilometers. And that is our answer for part A. Yay, we've solved that problem. So now going on to part B, which is also very simple. I'll use another piece of paper. So part B. Part B is asking us to figure out the how far apart. So basically what we want to do is we want to find from here to here. To do that, we're just going to find the magnitude of the vector we found in part A. So if we do that, Part B is going to be the magnitude of S minus P, which is essentially the square root of 3.12 squared plus 5.02 squared minus 2.20 squared kilometers. And if we solve that, that is going to be approximately square root of 3.40. Sorry, that's wrong. Maybe approximately 39.7748, which also equals approximately 6.31 kilometers. And that's our answer. That's how far the plane and the ship are going to be. Congratulations, we just figured out number 39. Have a nice day, guys.